Hello guys, welcome back to the next lecture which is based on model evaluation. There are two techniques for model evaluation. First we'll see how to perform model evaluation using Python, and second will be accounting for unequal error costs using Python. Now let's get into it. So the first one is how to perform model evaluation using Python. Model evaluation is a critical step in assessing how well your machine learning model performs. Here's how you can systematically approach it. The first approach will be train, test, split. Before evaluating, split the data into training and testing sets to prevent data leakage and ensure an unbiased evaluation. The second evaluate metrics are common metrics we have studied in the data science, which are accuracy, precision, recall, F1 score, and ROC AUC. So, what is accuracy? Accuracy. It is a fraction of correct predictions. What is precision? Out of the predicted positives, how many are actual positives? Recall, out of actual positives, how many did the model identify? And F1 score is the harmonic mean of precision and recall. Now let's get into the code of model evaluation in Python. So first we'll import the libraries. Now second we are loading the data. Here you can see that data is equal to load underscore breast underscore cancer. Here we are doing a breast cancer survey where we'll be adding xy is equal to data and data.target. So data set is preloaded in SkySet line, and X contains the features input and Y contains the target variable. Y X will be input and Y will be output. So now splitting data will be having syntax X train, X test, Y train, Y test. Train test split and data split into 70% training and 30% testing sets. That's why we have written test size is equal to zero point 0.3. This ensures that the model is evaluated on unseen data, avoiding overfitting. Now training the model is equal to random forest classifier, random underscore state is equal to 42. A random forest classifier is trained on the training data. Now making predictions in the y data, which is y prediction and y probability. So this is the syntax. See it. Y prediction contains the predicted class levels. It will contain either 0 or it will be 1. And y probability contains the predicted probability which will be 1. Now evaluating metrics, here you can see three or four evaluating metrics. The first one is accuracy. It measures the fraction of correction predictions. So it is the syntax of accuracy underscore score. Then we'll be giving two parameters, y test and y prediction. And will then print the accuracy classification report. This was the code for model evaluation. Now we'll next see accounting for unequal error costs using Python. In many real world problems, errors have unequal cost. For example, in fraud detection, missing a fraudulent transaction, false negative, is more costly than flagging a genuine transaction as fraudulent, false positive. In medical diagnosis, failing to detect a disease like many people can't detect their cancers and it become very late for them, so then this is used in medical diagnosis like that cases. And there are two techniques basically using weighted metrics which reflect the relative importance of false positive and false negative. It means that statement is false but it is given true, so that is the meaning of false positive. And second is adjusting the decision threshold. By default, models often classify based on a zero point 0.5 probability threshold. You can tune this threshold to prioritize minimizing specific types of error. Now, in the code of accounting errors, first we'll obviously import the libraries, then defining a custom cost function. Here, def calculate cost, y true, y predict cost, and function. CM is a confusion matrix, and then we'll taking all this variable. So calculate cost function uses the confusion matrix to compute error cost, which is false positive FP and false negative FN. मतलब false positive is incorrectly predicted as positive and false negative is incorrectly predicted as negative. This function calculates the total cost by assigning weights to false positive, which is cost FP, and this function calculates the cost by assigning weights of FP, which is Fn, which is false negative. Now, adjusting the decision threshold equal to zero point 0.4, Y prediction adjusted, then evaluating the adjusted prediction. Total cost equal to calculate cost, then print the adjusted threshold. So this was the code. Now, as summary is the difference between these tools are that basic evaluation code is it generally perform evaluation using standard metrics, which is accuracy, precision, recall, F1 score, etc. And unequal error cost is it handles scenario where different errors have different cost. We do not handle error and true or false, so custom cost function with weighted errors. And the threshold of these two are very not very different. Basic evaluation code has a default threshold of zero point 0.5, and in other case it has a basic default threshold of zero point 0.4. Thank you. This was